Good morning to all. Myself Priyadharshini from KSR College of Engineering. Today we are going to discuss a topic from compiler design. The topic name is the phases of compiler. Generally, the compilation process contains sequence of various phases. At the same time, each phase takes a source program is in one representation and it produces a output in another representation. Each phase takes inputs from its previous stages. At the same time, there are different types of phases of compilers are available. First one is lexical analyzer, then syntax analyzer. After that, the third one semantic analyzer, then intermediate code generator, code optimization, then code generation. These are all the phases of compiler. These are the various phases of compiler in each but generally source program as the input and target program will be the output. So first now let us discuss one by one of the phase of compiler. First thing is lexical analyzer. The lexical analysis phase, it is a first phase of compilation process. It takes a source program as input and it reads the source program from left to right and it converts the source program into tokens. So the input of the lexical analyzer is source program, output will be the token. Next one, syntax analysis. Syntax analysis is the second phase of compilation process. It takes token as input and it which is generated. It takes token as input and generates parse tree will be the output. In syntax analysis phase, the parser checks the expression made by tokens is syntactically correct or not. Syntactically in the sense syntax, whether the syntax is correct or not. The output of the syntax analysis parse tree. The third phase of the compilation process, semantic analysis. In the semantic analysis, it checks whether the parse tree follows the rules of language is correct or not. So that is the semantic analysis work. So it takes the input as parse tree. The output of semantic analysis phase is whether the tree is correct or not. So that is the semantic analysis. Next, intermediate code generator. Intermediate code generation. In the intermediate code generation, the compiler generates the source code into the intermediate code. So intermediate code is generated between the high level language and the machine level language. The intermediate code should be generated in a way we can easily translate it into the target machine code. The next phase, which is code optimization. The code optimization, in the sense, the name itself we can easily identify it as an optimization process. It is at the same time it is an optional phase in the phase of compiler, which is used to improve the intermediate code. So which in the sense, so that output of the program could run faster and takes less space. It removes in this phase it removes the unnecessary lines of the code and arranges the sequence of statements in order to speed up the program execution. So it is a optional phase. At the same time, it removes the unnecessary code. While we remove the unnecessary code, the program speed up should be increased. The final phase, which is code generation. The code generation is the final stage of compilation process. It takes optimized intermediate code as input and maps it into the target machine code. Code generator translates the intermediate code into machine code to the specified computer. Let us take one example of the phases of compiler. Just look at the example. Here we are having a code sum equal to old sum plus rate into rate into 50. So it is a source. Just consider the first line as it is a source program. The source program, the lexical analyzer takes the input as a source program. After that it generates the output. What will be the output of the lexical analyzer? That is a token. Now the lexical analyzer converts that source code into token. Sum is converted into id1, then old sum is converted into id2, then the plus as it is will keep it as a plus, then rate is converted into id3, then this 50, the number called 50 will be converted into id4. Here finally we are got 4 tokens, id1, id2, id3, id4. After that the id3, the in the second phase the syntax analyzer takes the tokens as input and it will produce the parse tree. With the help of the syntax analyzer produces a parse tree. Just look at this. Now look at the look at this parse tree. For this parse tree is a this parse tree is a this parse tree is the see, look at the parser. It is a corresponding for this tokens, it is a corresponding parse tree. Then semantic analyzer. The semantic analyzer whether check whether the parse tree follows the rules correct or not. So that is the work of the semantic analyzer. From the parse tree, the semantic analyzer checks whether the rules are, whether the parse tree constructed by the see here, look at here. So look at here in the semantic analyzers. Here we are having one constant, that is 50. That 50 is integer. Okay, will it is a the 50 it is a integer. We are in the semantic analyzer which is convert this integer into real. After that the semantic analyzer takes the after that next phase is intermediate code generator. From the semantic analyzer, intermediate code generator takes the semantic parse trees as a input, then it produces a intermediate code, and for this intermediate code it produces a temporary variable. It produces a temporary variable. Then within the temporary variable we can store that each and every IDs, each and every tokens. After that intermediate code, the next phase is code optimization. The previous session in intermediate code we are having four number of lines is available in the intermediate code. Now we are optimized this code in the within 2 lines.